So yeah, I'm going to talk about infrastructure as code. I'll give a little bit of background on myself. I'll wait till you finish taking that picture there. Okay. A little bit of background on myself and how I came about to write this book. So I've been working in IT and across kind of development and systems administration for the better part of 20 years now. And it used to be a really weird and unusual thing to work across those, right, and not kind of pick which one you wanted to be. But fortunately, it's now become a little bit more acceptable with this DevOps thing. But even before that, I was quite into automating things and using scripts and this kind of development mindset stuff towards infrastructure. And over the years, so DevOps came up, and DevOps as this thing of being about kind of culture and learning and measurement and all these kind of great things, the kind of clams or columns or however you want to kind of put it, and automation being one of the kind of cornerstones of that. And interestingly, automation is it's what a lot of people think of when they think of DevOps, even though the other stuff is equally and in many ways more important and harder to do. But I always found there wasn't much out there, or there's not much out there kind of in an organized way to pull it together and to explain to people how to do it. So I joined Thoughtworks about 6 years ago, and what I do there is I come in with teams where we're helping organizations to deliver software and work on kind of better ways of delivering software, agile and continuous delivery and this kind of things. And my role in those teams was to work with the ops folks, the infrastructure people, whoever it is that we needed to help us get environments and then help us to make sure that if we want to do continuous delivery, how do we make sure our environments are consistent from the full path to production? And in working with these teams, I found that people were adopting tools or adopting automation tools like Chef and Puppet, virtualization, and then now increasingly cloud. But they weren't really using them, they weren't getting the most effect out of them. They were kind of applying the same ways of working that they had with physical infrastructure to using these tools, and it felt like they were slowing them down. So I kept waiting for one of the kind of big experts in DevOps, one of the kind of big name folks to come out and with a book that I could give to people. And I kept waiting, and finally I decided to give it a go, and I talked to the folks at O'Reilly, and here it is. So this is kind of an encapsulation of patterns and ideas and stuff around how to do this beyond the tools, how to actually make use of the tools. So I guess to put this in context for yourself, think about in your own organization, how long does it take to do some of these typical tasks? So when I talk about doing something like provisioning a new server, for example, think about it from the point of view of somebody who needs to use that server and somebody from an application team, say, development team or whatnot, who says, we need to get a new server up that we can start working on it, and particularly if it's more kind of production or serious, not just a toy server. In your organization, how many folks here would doing that be on the order of, say, an hour or less? Fair number of hands, that's pretty good. How many would it be on the order of like a day or two and some number of days? A little bit less. And how many would it be like weeks before you can get something you can really use? Okay, that's a fair number and fairly common, right? So find that organizations are adopting cloud now. When we talk about cloud, there's public cloud like AWS and Amazon and those kind of things, and Google, Azure, and so on. There's also the things around it. There's things like containers and again, the automation software. So companies are really pushing to and starting to adopt this more and more. And why is it? It really is about that thing of speed, of how can we get those times down. And these things help because they remove the technical barriers to making a change. So when I started out, when I was doing systems administration stuff, if somebody asked me for a server, it would mean ordering hardware, maybe different bits of hardware from different vendors, waiting for it to come in, assembling it, taking it down to the data center, putting it into a rack, cabling it up, installing OS, all those kind of things. And so that took on the order of weeks, right? And so the process that we put around that was on the order of weeks. If you got it wrong, if you did all that work and then you found out, actually, we didn't kind of specify quite enough, we need more RAM or we need some faster hard drives or what have you, that had a pretty high impact, right? Because that was going to be a few weeks more and some money more to be able to correct that error. So you would spend a lot more time up front making sure you got it right. But But with cloud and these kind of tools, the time to do that is just minutes, right? You can click a button, run a script, whatever, and get a new server or make tweaks to the server if it wasn't quite right the first time. So yeah, that's all great, but the problem is, and especially as we get into this being used on more serious things. So on projects that I worked on for, up until maybe a year or two ago, they tended to be more kind of pilot projects, or they were kind of outside of the mainstream. So they were somebody in an organization, especially the bigger companies, who would be, that had some commercial things, something they wanted to get to market quickly and try out. And so they would say, in order to do that, we need to bypass our existing IT department. So we're going to spin up a new project in the cloud and kind of leave that behind, because the process that they insist on is just too much. It takes too long to get things done. But now things are kind of moving to a point where cloud is coming out of that kind of shadow IT world and becoming mainstream. Organizations are finding that either the stuff they've built on these kind of pilot projects and test projects have become important enough that they need to take them more seriously. And also the rest of the organization is saying, hey, we want to do this as well. So the IT organizations are kind of have moved beyond fighting cloud and saying cloud isn't something that you can do for serious stuff, it's just toys and startups. It's now become something that everybody's realizing we have to figure out how to use it and how to get this speed. But the pitfall is around the risks and stuff. So if we've lowered the technical barriers for making a change, what about, we still have to think about security, we still have to think about stability and resilience and all of these kind of things, operational qualities, non-functional requirements. And the tools by themselves don't, if you just kind of use them in the way that we've been using them, they don't kind of help you with that necessarily. So the kind of mindset that we've had, I think, is that you have to choose between either doing things very quickly and just kind of like, don't worry about rules, don't worry about doing it right, just get something up quickly and damn the consequences. Or you have to do things very slowly and properly and carefully, and that you're either going to do things quick or you're going to do it if you don't do it quick, you're not going. You either have to choose between doing it quick or doing it right, basically. And that's a false dichotomy. So, how many folks are aware of the state of the DevOps report? Fair number. So this is a report that the folks at Puppet and some other organizations got together, and they do every year. And they do research on different organizations and how effective they are at IT, really. And it's interesting, the correlations they found. So they found that as opposed to finding that the organizations which are most effective and have the most kind of resilience and the most success at doing releases being the ones that take their time and have longer release cycles, it's actually the most effective organizations have faster release cycles. They release more frequently, and they have fewer failures when they release. And they their staff spend less time remediating errors and fixing things, and they also tend to be commercially more successful. And while that might be counterintuitive at first, it kind of makes sense that if you're, the more often you do releases, the better you're going to get at it, and the more you have to kind of invest in the tooling, and the better your processes have to be able to make changes very quickly without failure. So that kind of makes sense from that perspective. And I think it also makes sense from the perspective of quality. It's kind of like a broken Windows thing. If you are looking at your systems and you find that, here's something that's kind of wrong with the system, and maybe it's not breaking something at the moment, but it really ought to be fixed. Well, if it's going to take you weeks or months to get that fixed, and lots of conversations and documents and explaining to people, justifying and all these kind of things, you're not going to do it right. You're going to put it on the list of known issues and hope that we get to it at some point, and hope that somebody happens to fix it when they run across it. Whereas if you can fix that thing within minutes or even within just a couple of hours, if it's a very low effort thing to do to fix and improve the quality of your system, you'll do it more as a habit. And so it raises that kind of bar, I think, across the organization to keep technical debt down. So what we're after is a way to be able to make changes rapidly and frequently, as well as making them responsibly and safely and reliably. We want the change process to be something we can do easily. So obviously automation, the tooling helps with this stuff, but how does it do it? Well, first let's look at some of the pitfalls, certainly the things that I fell into when I was first doing automation and using tools like Puppet and Chef. So one thing was when I first got virtualization servers, it was really great in that when somebody came to me and asked for a server, I didn't have that, it's going to take me a couple of weeks and I got to order stuff, take it down to the data center. Now I could just click some buttons or run a script on my VMware server and spin up a new server instance. And that felt really good to be able to help people out that quickly. But I ended up with hundreds of servers. And they all ended up being a little bit different. So we might say a couple of people asked me for some Java application servers with Java installed on it. Fine, I take a single starting image and create it, and so they're exactly the same. And then somebody comes along and says, oh, we got this problem on one of the servers. And so we go and we look at it, and we fix it by making a configuration change to that server. Now it's a little bit different from the other server. And then the people on the other servers say, we need a newer version of Java. And so I say, okay, we should upgrade Java. And so we talk to the other team and say, well, we can't, our application won't run on the new version yet, and we don't have time to kind of update it right now. So we end up installing, updating the Java on one machine. And again, they become different. And all these things build up. And you get a lot of differences between your machines. And so we had Puppet, and the idea was that would help us with this, right? We could write a Puppet module that would define how an application server, all the kind of things on it, and we run it across all of our servers, and everything will be the same. But we found that it was difficult to trust it to do that, because we would write that Puppet module, we would run it across our machines, and some would break because we had those differences. And so that led us to say, well, we're going to use it more tactically. So we write the Puppet module to install Java, and we tweak it to be this version of Java and run it against those machines. Then we tweak it for another version of Java for those machines, some other differences. And it becomes more of an interactive tool and not something that's kind of really managing everything across the whole piece. So infrastructure as code, the way I define that is it's about taking, because our infrastructure has moved from being kind of physical, and at least in the ways we deal with it, to being it's essentially become software and data. So we can start applying tools and practices and so on that we've found are really good for software engineering and apply those to our infrastructure. Things like test-driven development, continuous integration, continuous delivery, tools like version control systems. We can start bringing those to bear. So some of the core principles on this is that we should be able to rebuild any part of our infrastructure, any part of our systems very easily. And by easily, I mean not only is it quick and not only is it kind of repeatable and we know it happens the same way every time, it also shouldn't take a lot of kind of thinking. If we've got an existing server and for some reason either it goes down or we want another copy of it, we shouldn't need the person who knows that stuff. We should hear the script that we run and it just happens, and all the thinking has been encapsulated in our scripts and our tools. And that lets us treat the bits of our infrastructure kind of as being disposable. We can kind of bring up something new and improved. We can throw away the old things, and we can be a lot more relaxed about stuff as opposed to those kind of snowflake servers, the things that have been carefully configured some way that nobody's quite sure how to reproduce, and so we're afraid to touch it. We can be a lot more confident in how we deal with our infrastructure, that everything is consistent. So when we think about things like those Java servers that need to have different versions of Java, we can kind of encapsulate that and say, okay, we've got ways to define our Java 6 machines, our Java 7 machines, and yes, they're different, but they're defined, that difference is all kind of captured. And we don't have an end state. I think this is an important thing. There's the idea of evolutionary architecture. So I think our kind of habits as technical people is we like to, we look at our current state of things, we can draw it up on a whiteboard and say all the things that are wrong with it, and then we go to the whiteboard and we draw what it's going to be like. After we get these new tools and stuff working, and after we've kind of gotten over this project or program or whatever it is, everything's going to be awesome. But the fact is that end state never really happens. Things change along the way. And if we accept that, and if we kind of organize ourselves and our ways of working to assume that we're constantly going to be changing this stuff in our infrastructure rather than striving towards a perfect end state, we get more comfortable with that, and we can handle the kind of changes that come at us more easily. And it also reduces the tensions around decisions where we have those discussions of which tool are we going to use. Should we use, these people want to use Chef, these ones want to use Puppet, and we're kind of arguing all the time, and we don't move forwards because we're having these discussions. Well, if we accept that, we can pick something, and then as we go along, we'll learn and we'll change, we'll adapt. So it takes the stress out of those things and helps us move forwards more easily. So I'll get a bit more into some kind of practices and patterns around infrastructure as code. This is the kind of stuff that I talk about in the book. So the most basic thing is you define your infrastructure as code. So you want to have files where you're saying things like, okay, and most familiar with things like Puppet and Chef, where it talks about what goes onto a server. Where do you install Java? What user accounts do you need to run your application server? That kind of thing. But also at the higher level of So what about our networking rules? What about firewall rules, load balancer rules? What about the kind of storage and stuff like that? We want files like, so at the level of things like Terraform or CloudFormation or these kind of tools, where we can capture those things into files. And that's great because now we can reuse those. We can say that we're going to define what an application server looks like and the bits that need to be around it. And then we can reuse that. And that starts to reduce the pressure on things like, whereas previously every time somebody wanted to create an application server in a larger organization, you might have to have a lot of process around that, a lot of discussion, drop specifications and everything. But you can say, actually, we're just going to use the same files that have been used and have been proven to define our application server, and you don't need as much of the kind of bureaucracy and process around that. There's also the usefulness of making things visible, of saying that we've now got what an application server looks like in a file that anybody can look at. And that particularly helps in organizations where there are kind of legal regulations, things, compliance becomes an issue. And those organizations, when you come in to have an audit, having things captured in a file and having tools that you can point at to say, this is actually what our infrastructure looks like. This is actually how an application server is built, not just what it says on the wiki page, which might be how it's created or might not be, depending on whether it's up to date or whether somebody who happens to install a particular machine knows a better way of doing something. We have auditable proof of that, and everybody new to the team can look at it and understand it as well, rather than having to kind of figure it out as they go along. So once you've got that, you've got your stuff defined in files, you can put those into version control, and you can do continuous integration. You can say that every time somebody makes a change to how our application server is configured, you can automatically spin up an application server, run some tests against it to make sure it all hangs together, not just to make sure that it's correct and works the way it should work, but also things like security. Are there ports open that shouldn't be open? Has somebody installed a package now which creates user accounts or run services that we don't actually want running? So you can kind of put all kinds of stuff into the automated testing and validation that you do on your changes. And then that lets you move on to continuous delivery and say, we're going to actually use this to promote stuff across environments. So that in each of our environments, we're going to, when we spin up an application server in our QA environment or our production environment or wherever it may be, we're going to use a file that's already been tested previously. And so again, we have that confidence that it's consistent and that it's going to work across all the environments. And I've done something that might seem a little counterintuitive or a little strange to folks, which is I put the pre-production very early on in the pipeline. And this is something that's become I found a useful pattern, particularly with kind of application development and these kind of things, where we often have folks who are responsible for production and want to make sure that an application is meets their requirements before it can go into production. And the traditional place to do that is right before production, to say wait until the team's been working on stuff for a while, maybe months, and right before it's ready to go, then we'll do it on a pre-production environment and we'll see if we're ready to accept it into production. Well, that's a bit late, right? I mean, what typically happens at that point is that people find issues, they find things that they don't really like or aren't quite right, maybe some kind of security things. And then what happens is they raise those, and the kind of commercial stakeholders, the people who've spent loads and loads of money on all the development work that's gone into this, have said, oh, that's a shame, but you know what, we're gonna have to go live anyways, right? We can't, not release it, right? So maybe you'll get a few days to kind of do some quick hacks and workarounds, and then the promise of once it's live, we can go back and we'll clean it up later, right? And we all know what happens to that, which is that it goes on the list of known issues and doesn't get cleaned up later. And that's where technical debt comes from, right? From those kind of rush things. So what I like to do is to get the people who have these concerns, the security folks, operations folks, whoever it may be, the people who can say no to a release going or want to be able to say no to a release going through, get them involved in designing the pipeline, designing how do we define infrastructure, how does it get applied to an environment, what kind of tests do we want to run, and let's run that stuff early on. So on every commit throughout the day, really, we should be continuously validating every time somebody makes a change. Is there anything wrong with it that's going to mean we can't put it into production? Let's find out then before we even waste a human's time of doing like exploratory testing on it. So an important kind of enabler of all of this is to have small scope changes. And this is, I mean, this is pretty standard stuff in terms of continuous delivery and even agile. It's just the idea if you can reduce the scope of your change, it becomes easier to test, becomes easier to think about it, becomes easier to look at it and analyze. And if something goes wrong, it's easier to debug. So it's about changing our habits and our ways of working in order to be able to, again, continuously throughout the day make the changes. And even if we don't push each change immediately through to production, that's fine, as long as we can validate each change as thoroughly as possible. And then that has to impact the design of the system. So one of the things, as with continuous delivery of software, as with automated testing, it tends to be very difficult to take an existing system that hasn't been designed and grown and evolved with this stuff in place and then retrofit. So you tend to have to think about the architecture of your infrastructure, how your things are organized, and how can you potentially refactor things and break them down into smaller bits. So I'll talk a little bit about that in a minute. But I'll go back to that thing. I remember I was saying earlier about the that there is that fear spiral of saying that I can't trust my automation to run across all of my machines because we've kind of done things more tactically and more interactively with different sets of machines one at a time. Well, the solution to that is to continuously reapply your configuration. However it is you define an environment in your configuration, you reapply that all the time, so that tools like Chef and Puppet are meant to run on a schedule, to have agents running on your machines that do kind of every hour or so reapply. And this kind of forces some discipline. It forces you to make sure that everything is captured in your automation. And so therefore, if you've got a change that somebody makes that's either outside of the automation or that is going to fix this machine but happens to break that machine, you should find out quite quickly. Ideally, your pipelines and your automated testing should find out before it hits production. But even if it does hit production, you then are made aware, and you should kind of correct it and put it back into the automation as quickly as you can, just to make sure that that becomes the easiest way to manage your changes. An alternative to having those tools running continuously is to do what some folks call the Phoenix pattern, or immutable servers even, which is to say that we'll just rebuild machines to make configuration changes. So we don't let machines live very long. So I worked on one project where we were more or less doing this. We were rebuilding our machines probably every few days. But one of the developers on the team we talked about this stuff, but it wasn't something he was used to. And so he decided he needed an FTP server, directory repository for packages that he could put some packages onto. And so he picked one of the development servers and went and installed stuff by hand, configured a web server and put his stuff on there, and was happy for, I think, about 2 days until suddenly it was gone, and he was like, what happened to my package repository? And so that was when we had this, oh, actually, this is what happens. And that actually helped. So then he got it. He got the point of how this stuff works. And we went and put into the automation. So we made some definitions for a server that would be able to host his packages and be kind of continuously configured. And so again, this is part of that discipline, enforcing that discipline of saying everything's got to be in your automation, or else it's going to disappear. So I'll go through a few pipeline patterns around infrastructure. So one is the basic pipeline. Is this kind of minimum pipeline here is saying, let's have, say, our application code, maybe some server stuff in Puppet or Chef that defines, again, our application server is my favorite example, an environment stack, and something like Terraform, which says this is the load balancer and networking security groups and so on around this application. So those goes into a source repository, and first we have a build stage which runs and just does the kind of basic validation on those things. Depending on the tools we're using, we might be able to have some unit tests run on those. At the very least, we can do kind of syntax validation and just make sure that it's we can do the kind of quick validation things on it. And if those pass, we move on to an automated test stage where an environment is automatically brought up and configured, and then we run some tests against that. We might use something like server spec to test, does our application server hang together the way we think it should? And then once that's passed, it becomes available to a human tester to trigger it to be deployed to an environment where they can do that kind of exploratory testing and whatever they need to do to be reassured that it can go on and before we go to the production stage. So that's a pretty simple pipeline, and then you can kind of expand on that, add stages depending on what it is you're building and what steps you need to validate something to go to production. So then you get into things where you start wanting to share code. You have multiple teams working on things. And so a very common pattern is kind of a library type of pattern. So let's say we want to have a server. Let's say we're using AWS and we're going to have an AMI that we're going to build that installs our application server stuff, the basic stuff on there, so that creating instances of application servers is very quick because we don't have to for every time we make a new server, we don't necessarily want to have to pull down all the things. We'd like to have it prepackaged on there. So we can use a tool like Packer, which lets us define what we want in our AMI image and how it should be built in a file. And we can put that file into a version control system, so at the purple kind of box up there. So when we commit that file, we might do a build stage, which does a very simple validation, and then creates an AMI image. And a new version of our application server AMI. And then we can do an automated test on that. So we can spin up an instance of that that new version of the server if we made a configuration change to it, run tests against it, and only when we do that do we make it available for application teams in their pipelines to say, for our automated test environment, we're going to use the latest application server image that's been created. I learned to do this the hard way. So I was on a project where we were using Chef to build our hosts file, or Etsy hosts file on our machines, because we didn't have access to automatically configure our DNS. And we wanted to make sure that an application server could just connect to hostname DB and it would go to the right one for the particular environment it was in. So we built that dynamically using Chef. And then I committed a change that broke that. So the hosts file got mangled, nothing could talk to anything, you couldn't talk to any of the machines, couldn't log in or anything to fix it. That was pretty disastrous. It didn't go through to production at least, but it did go immediately. At that time, the way we had our pipeline structured, we would test these things on our application test environment, which meant when I broke the application test environment and the QA environment, we couldn't, people couldn't develop and push their code and run CI, and testers couldn't test it, and it made them very unhappy. My colleague called that DevOps. Yeah. So that just kind of led me to use this pattern of let's take the infrastructure stuff and run that through tests before we even inflict it on the developers. Development environments they are business critical, right? If they go down, then a lot of people are not able to work. Now, what if we want to share infrastructure kind of a bit more widely? So this pattern we used. I worked at Auto Scout in Munich about 2 years ago, and we did this. And I just caught up with Christian Dager, who from Auto Scout, who's actually talking another talk right now. And he said he was going to show a slide about my book. So I said I'd mention that some of this stuff that I learned with you guys. So here it is. So this was the idea of the global stack. So we were on AWS and we're using CloudFormation. And so what we did is we wanted to have multiple applications or multiple services running in some overall kind of networking structure, basically. We only wanted to create this once and be able to run multiple things into it. So we had a CloudFormation file, which defined some things like VPCs and security groups and shared things like that. And then we had separate each application, which different teams were developing their services, and each of those would have their file, their CloudFormation file, which said, here's the stuff that I need just for my own service within that. So that was the Elastic Load Balancer and auto scaling group, and the definition for what server to actually create there. And then that would plug in to the overall stack. And so the pipelines for that, the way they looked was that we had basically one pipeline for the global stack, and then each application stack had their own pipelines. So the global stack would be, again, this is a CloudFormation file. We check it into version control. There's some other stuff as well, some scripts and stuff around that and tests. We commit that to version control, and then some basic checks happen on it. And then we created a test environment. So it would spin up, or use that CloudFormation template to create all that little infrastructure. And it also had like a little test service that it would create. And then it would run some server spec tests just to make sure that everything talked to each other, all the kind of connections were working correctly. And then after that, we could push it into production. And for the services, and that was kept as minimal as possible. This is one of the kind of things, and that's one of the things they've really kept to. When I was talking to Christian over the past 2 years, they're still using this pattern. But one of the really important things was keeping that this thing really minimal, so that you don't have to change it very often, so that the impact of changing it is less, and you're kind of less scared to change it, which is really what we're after. So then the pipelines for the service stacks are just, they'll grab for their tests, when they're spinning up an environment for automated tests, they grab the production version of the CloudFormation stack from the global stack. So they don't kind of take a test version. Instead, they know if this test passed, it's going to work in production as it is now, or it should work in production as it is now, not kind of in a potential future point. And then that gets applied, to each of the further environments when they deploy within that. So in this one, the first stage, this is the only application. This particular service that's testing it is the only application running in that instance of the global stack. So they just make sure, regardless of anybody else, I'm okay. They use things like mocks and whatnot to kind of worry about dependencies on other services. And then they might have a stage that has more kind of other services deployed with it so that they can test them together. In actuality, at Autoscout, they're bolder than this. They don't have this stage. They go pretty much straight into production, and they do a kind of a canary release pattern. So they deploy their service into the production stack, but keep it offline so they can test it and then swap it out once they're happy with it. So the last kind of section of what I'm going to talk about tonight is around there's some basic design patterns, and particularly around how do we avoid kind of a spaghetti monolithic infrastructure, which is a problem a lot of teams are getting to these days, where people who've been using Puppet or Chef or these kind of tools for quite a while, for a couple of years, the code base has grown, and it looks like any application code base has grown over quite a lot of time, that you got a lot of technical debt and a lot of kind of spaghetti going on. So if we look at let's say a set of applications and services that are interrelated, some front-end stuff and middle stuff and maybe monitoring and all that. The naive way, certainly the way that I first did this when I got my hands on Terraform, was to make a file that just defined all the stuff. Seems like a good idea, but it's the same thing as with software, right? It's a monolith, right? And it becomes difficult to make changes, because if I make a change to something around here, I might break something over there. And that leads us to want to have process, right? So we start discussing, we need to have more kind of ceremony and process around making changes to things and discussions across the team, and that just slows everything down, which kind of gets us back to the old school change models that we wanted to get away from. So the first thing that you look at for this guy is the modularity. Is in Terraform and CloudFormation and these other tools, you have ways of saying, I want to define something like, let's say, a load balancer, bit of my infrastructure, and you can pull that into a separate file, and then you can reuse that file. And that's really handy. It starts helping you to organize your code a little bit more cleanly, and it helps with sharing and reuse of code, so you can have multiple people using that single load balancer definition, which is nice. But actually, as with code, it does increase your coupling. So in some ways, it can actually make changes more difficult, because, again, if I want to change that load balancer file for the needs of one application, I now have to worry about, am I breaking other applications? And so, again, I have to go back to needing kind of process, or what client recently talked about having to, at a bank, they talked about having for every change, they have to test the bank. They have to test the full bank for every small change. And so modularity, while it helps in some ways, it doesn't kind of get away from that problem. So now we can look at, well, let's split up our infrastructure. Let's split up those Terraform files or CloudFormation files. And a kind of obvious way to do it is by kind of layers. So we have the front end and then the kind of application servers and the databases. And this kind of aligns with the way a lot of applications have traditionally been architected, and also the way infrastructure tends to be architected, in that we have our kind of security, we have firewalls in between these layers, right? This is a very typical infrastructure diagram. But there are flaws with this, right? And this is where the whole thing with kind of microservices and all this comes from, is this idea that actually when you start thinking about the scopes of changes, not the individual changes of saying, okay, I want to change a load balancer rule for the web server, or I want to change, open up some ports or whatever for down in the application server layer. Those are probably serving some higher purpose, and so you want to be able to think about the actual value you're trying to deliver, and that's going to tend to touch multiple parts. So that the layering thing doesn't work that great. It means that you still end up having to change across multiple files in order to make a single change, which brings you back to how do we coordinate this stuff and avoid breaking things. And also for security, I think as a security model, this is kind of the standard, what some people call best practice, to kind of divide things, put firewalls between these things. But that's actually, you're still kind of leaving, you tend to have very flat things in here, which are very insecure. So if somebody does gain access to somewhere, they get access to a lot of stuff you probably don't want them to have access to. And with cloud and with the ability to define things in code, we have the opportunity to kind of slice things up in ways that make a bit more sense. So we can say, along the lines with kind of microservices, we might have a single microservice that runs on a little cluster, and then a little database for that partitioned in some way. We can have a single file which defines that. So you have a team that owns that, and they tend to have a file which controls the stuff that they work with, and they don't have to have so much coordination with other people. So just to sum up, really, I think the underlying principle is to think about how you're going to manage change and what the typical scope of change is in your organization. You can do things like value stream mapping to analyze that and look at who's involved and what parts of your infrastructure are involved. And ideally, you can work on your infrastructure, your architecture, your design of your software and your infrastructure and your organization all together to optimize for this thing. And I think that's really the goal. So thanks a lot, and I'd like to hear if anybody's got questions or particular challenges they've got around infrastructure management and cloud. Thanks. Did I see a question here? No, sorry.
We got 3 questions via the app.
Oh, okay, awesome.
So first one, how do you manage database changes in the CD pipeline?
Yep. So a couple of things to do. One thing is, in line with what I was saying around overall architecture, being able to design your systems or redesign, refactor your systems to kind of shrink the scope of things, so that rather than having like a single database that's got everything, if you can kind of split that up so that you're kind of managing chunks of data around the kind of business context. That helps to reduce the scope and make it easier to manage things in the pipeline. So that's one thing I'd recommend. Another is managing changes to your database schemas in a way that is essentially code-driven. So there's tools like dbdeploy or flyaway or even Liquibase, which lets you define your database schema in a file, and then you define changes in files and put them into version control, and every time you make a change, you have a tool that applies those to the database instance, and so you can progress that through the pipeline. And that's very kind of compatible and aligned with continuous delivery. I'd recommend there's a couple of posts on Martin Fowler's Blicky that he and a colleague of mine wrote around evolutionary database architecture. They also have a book about that. And so that's a good resource for thinking about those kinds of things. And then a couple of others. This is a big topic. And I always get asked this. I should add some slides probably. So another couple of things are thinking about how you can architect your database so that it's essentially can become highly reliable and redundant. So if you have like multiple nodes in a cluster across availability zones in the case of a cloud or some equivalent kind of thing, and the ability to kind of add and remove nodes quite flexibly to a pool, and obviously some databases make this easier than others, but it's a really useful thing to being able to kind of keep everything very flexible and rebuildable. And the last one is just a kind of pragmatic thing around, in pipelines in particular, being able to kind of snapshot data sets and kind of reload them. So like in a test environment, you might want to kind of every time you do a deploy, you kind of refresh the database to a known state before you run tests against it. That can be quite helpful.
Okay. Which kind of tools you suggest to do auto testing or automated testing of your infrastructure as code created results?
Okay, what was the last part? Created results.
So that's the question.
Okay. Yeah, I understand. Yeah. So things created with infrastructure as code. So the way to approach kind of automated tests and tooling is in the kind of the test pyramid, and I talk about this in the book, and it's very it's basic for agile, extreme programming type things that talk about testing. And it's the idea that you have testing at different levels. You have the kind of unit testing that happens at the lower levels of things. So tools like Chef and Puppet, which have been around for longer, tend to have a pretty strong ecosystem of tooling to help you with automated unit testing at that level. And then you want to test at kind of the higher level when you start to bring stuff together. And I quite like server spec, which is it's essentially a set of libraries for RSpec, the Ruby testing tool, which let you assert things about servers like this user count exists or this file exists and has this content or what have you. And then there are some other tools around that help you to kind of glue things together. So things like Test Kitchen, which let you manage like spinning up a virtual machine very quickly and then running tests against it and automating that process and defining that in code. Can be quite helpful.
Last question from the app. Do you think artifact stores are a good fit for different component versions?
Yes. So we didn't really talk about artifacts and how they're managed across pipelines, but for artifacts can be lots of different things, and they tend to be lots of different things in infrastructures. You have things like RPM files or Debian files for your system. You might have Ruby gems. You might have Java files in like a Maven repository. And then you also have just the files themselves. Those CloudFormation or Terraform files are things that you kind of want to move through from one environment to the next. And you want to kind of version those. So you want, when they go into the version control system, you want them to kind of come out and the things that go together. So you might have multiple of those things which kind of tend to walk through the pipeline together. It's nice to have them versioned as a unit and stored somewhere that you can kind of progress them and refer to and roll back and say, I want the version 102 of my environment, and that might include the Terraform file and some cookbooks and whatever else go along with that state. I hope that kind of gets to the question.
Okay.
Hi, do you have a suggestion on how to deal with secrets in repositories? So API keys and whatnot.
Yeah, secret. So I mean, obviously number one is don't check them into your version control. And that's especially, even if you have internal private version control repositories, I do, a lot of people kind of think about, we don't have to worry about it so much in that case, but if you've ever seen how hackers work when they kind of, the ease with which they can get into your private network is just trivial and scary, and the first thing they go for, I saw a speaker at QCon last June in New York who was walking through what she does when she breaks in and how easily she got it, even with an organization, a big organization that used two-factor auth, she managed to get into that with a couple of days of social engineering. First thing she goes for is the development tools, your CI server, your version control systems. And I used to think that was because of, she's going to hack my code, right, and put in backdoors. No, she goes for your passwords and your databases. And those are the soft spots. So we need to, I think, get better as an industry at tightening those up. For keys in particular, some people, there's a couple of tools, I can't remember the names off the top of my head, which let you essentially encrypt keys if you want things that you want to store in your version control system, your source control repository, and that can be helpful. I think there are some good secrets management systems out there. Things like HashiCorp's Vault is quite cool in what it can do. So I definitely recommend looking into those kind of things as ways of storing secrets. I think ways of trying to eliminate or reduce the scope of things. So one of the cool things about AWS is the kind of IAM roles where you can assign to certain machines the permissions to do certain things. So you can have like your a CI agent, have the permission to kind of create infrastructure to say run Terraform for you. And if you can kind of reduce down the scope and say that actually doesn't require then people having a password or a key, or that you can do it through the kind of encryption where you go off to a server and get the permission to do that stuff. It's a big topic, and I haven't found a lot of really good kind of resources on how to pull it all together. But I hope that helps a little bit. Is that, yeah, somewhat. Yes. Okay.
Hi. Is there any experience, not talking about cloud, but for example, with our client, pre-production and production is hosted by a company. We occasionally have the need to quickly recreate the current production state. Mm-hmm. We would prefer, of course, to use some cloud system, but the main problem is really getting everything from server configuration from the production system to get the information itself, because they are really reluctant to use any kind of version control so we can share. And we would need so much. It starts with Apache configurations, dispatcher configurations. Is there any experience how to ease into this process, how to get reluctant hosters to work with you?
I think a lot depends on the particular situation and what the constraints are on that organization, what the kind of where the resistance comes from. It can often help to find problems that they have that they would like to solve and to talk about how this can help. So if they get frustrated by, getting deployments, releases that you give them, and then they have trouble configuring it and getting it to work, for example, we can talk about how automating and creating consistency between the environments can actually make their lives easier. That's often a good way to kind of go into it. In general, when it comes to introducing automation around infrastructure, I think it's good to kind of start small, start with a particular area, and ideally something that you can kind of build up from scratch, as it were. So rather than saying, how do we take an existing system and then we run maybe Ansible or something on some part of that system, that can run foul of, if the systems underneath are inconsistent already and different, that tool is just going to break, or it's going to break in some situations, and it's not going to have the level of trust. So I think you have to start with how do you build the server image to start with and make sure it's consistent. And if you can do that for some subset of things, that can help. But it's complicated. I don't think there's an easy pat answer to give without kind of getting more deep into the situation.
One final question. Nobody? Okay.
All right.
Thanks.
Thanks again for coming out.